class. So today we're going to learn about probability trees. Now for this lesson you will need a pen, notebook, and your homework sheets from last lesson. So if you can remember these two sheets, you had to do a table about different flavor cookies, determine the probability, and then these questions. So if you can see here, if you can get ready and find these sheets. Now some of you sent me the answers. I'm still not getting everyone's homework, so I'm hoping you guys are doing these sheets at home. If you can, please take photos and send it to me. So we will check this homework, okay, and then we move on with our next topic, and we will review the probability today. Okay, now these are the sheets for this lesson, okay, so after this lesson is over, you have to complete these two sheets about the probability trees. I will explain a little bit more about this homework later. Now, so let's check your homework. Okay, now this is the first sheet. So if you can see here, there was a question about cookies. So a cookie jar contains 3 chocolate chip, 5 raisin, 11 Oreos, and 6 almond cookies. Find the probability if you were to reach inside the cookie jar for each of the cookies above. So if you just put your hand in and pull out any of these cookies, what's the probability? Now these are the answers. So we had to get the total of the cookies, which were 25, yes? And then we had 3 chocolate cookies. So the fraction would be 3 over 25. And the decimal then is 0.12. Okay, we had to divide 100 by 25 multiplied by 3. And then we get 12%, and ratio is 3 to 25. So 3 chocolate cookies to 25 in total. Now raisin is, we're going to repeat the same process. So as you can see, this fraction has been simplified. So 1 over 5, 0.2, 20%. Okay, now there are more raisin cookies than chocolate cookies. And 1 to 5. Oreo, 11 over 25, 44%, and almond, 6 over 25, 24%. Okay, so these are the answers for that. Now a card is chosen at random from a deck of 52 playing cards. There are 4 queens and 4 kings in the deck of playing cards. What is the probability the card chosen is a queen or a king? Now we have to add 4 plus 4. So we have 8 possible outcomes. We write 8 over 52 and we simplify and we get 2 over 13. This is the answer. Now let's move on. If you need more time, just pause this. Let's move on to the next sheet. Now a thumbtack drawing pin can land either like this, point down, or point up. Drew dropped the thumbtack 100 times and found that it landed point up 38 times. Drew concluded that the probability that thumbtack lands points up is about, so out of 100 it would be 38 over 100, so 0.4 or 40%. Okay, so it's about 40% chance. So this is the decimal, or we could write it as 38 over 100, and it's for about 40% that it will land point up. So more times it would land like this. Now probability using a spinner. So these have answers. As you can see, there are 8 possibilities, okay, but then we have 2 of each. So we have 2 1s, 2 2s, 2 3s, and 2 4s. So what is the probability of a spinner landing on 3? So we write 2 over 8 because there are 2 2s. So 1 and 2. So 25%. The same for landing on 2, 25%. Landing on 1 or 3. So we add 2 plus 2, which is 4. 4 over 8, a half. Do you have an equal chance of landing on either 2 or 4? So I would say yes, because there are 2 2s and 2 4s. What is the probability of landing on 3? 25%. So we had this question already, just repeating to see if you guys are all awake. Do you have an equal chance of landing on either 1 or 4? Yes. And then this one is 50%. So these are the answers. Now last question. Lawrence is the captain of his track team. The team is deciding on a color and all 8 members wrote their choice down on equal sized cards. If Lawrence picks one card at random, what is the probability that he will pick blue? Now there are cards that had free there are free blue cards. Okay, so you can't see the picture here, but there was blue, blue, blue. So 3 people wrote blue. So there are 8 cards altogether. So we write 3 over 8, and we get about 37.5% that they would pick blue. Okay, so this is the answer. Okay, hopefully guys you've checked your homework. So this is the homework. If you need more time, just pause it to check it. Thank you for sending me your homework. Now I really do hope that everyone is trying to do their homework, because it will be easier when I come back and we do a test. So please continue working on the things that we send you. Thank you guys. Now we're going to watch this video about probability, a little bit of review, and also something new that we're going to learn today about probability trees. So I just want you to listen and see if you can understand something more before we look at it in more detail.
Hello and welcome to Teen Topics, where you'll learn all you need to know about probability. Some things are likely to happen, some things are unlikely. Some things are so unlikely that they are impossible, some things are so likely to happen that they are certain. Some things that seem unlikely are actually quite probable. Sometimes the reverse is the case. Mathematicians who want to work out how likely something is rate probability from 0 to 1, where 0 is impossible and 1 is certain. Probabilities in between 0 and 1 are neither certain nor impossible. The closer they are to 1, the more likely they are. Let's think of a few examples. A coin is tossed. Will it either land on heads or tails? If both are equally likely, then each will have a probability of 0.5 or a half. A dice has 6 sides, so each number should be equally likely at 1/6. In both cases, the total probability for all options is 1. 6 times 1 divided by 6, or 2 times a half. The probability for all possible options is always 1. Things get a bit more complicated when you start combining events. For example, the probability of throwing 2 sixes on a dice in a row. The probability of throwing a single 6 is 1/6, but the probability of throwing 2 in a row is 1/6 times 1/6, which equals 1/36. Sometimes drawing a probability tree can make probability problems easier to understand. Here is a probability tree for the simple example of throwing 2 coins. Each coin can land on heads or tails, and each outcome is equally likely at a half. Looking at the tree, it is easy to see that throwing 2 heads or 2 tails has a probability of a quarter. Throwing one of each is twice as likely at a half. This is because 2 branches of the tree show that result. Throwing a head and then a tail, or a tail then a head, both satisfy the condition, and each has a probability of a quarter. To find the probability, simply add up the final probability figure for each branch of the tree that complies. In this case, 1/4 plus 1/4 equals a half. If you wanted the probability of throwing at least one head, then 3 branches satisfy that condition, giving a total probability of 1/4 plus 1/4 plus 1/4, which equals 3/4. Another way of looking at it is to find the probability of not getting any heads, which is 1/4, and taking that figure from 1 to get 3/4. Remember that the final probabilities always add up to 1.
Okay. Now, if you can please open your notebooks, and we're going to write this down. So our next topic, or our next heading, is tree diagrams. Okay, so we're going to look at how to show probability using a tree diagram. So if you can write down way of organizing and visualizing outcomes. So tree diagram is shown here. Okay, it's shown here on the right, and this is an example of the coin toss. So you just need to write tree diagrams and way of organizing and visualizing outcomes. Okay, it shows you there. Okay, the arrow points at the thing you need to write down. Now you can pause this lesson and write it down. I will just wait another 5-10 seconds, so please copy this. Tree diagrams, way of organizing and visualizing outcomes. And it shows here what it looks like. Now we look at it in more detail. Now let's move on. So probability tree, it's also shown here. Now to show probability, there are 3 different ways. You can have a list. So you can see there it says head, 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 tail, tail, head, tail, tail. This is for tossing a coin. Or you can have a table, or you can have a tree diagram. So today we look at tree diagrams. Okay, and a tree diagram is like a drawing that shows the probability. Okay. Now, tree diagrams can help when calculating probabilities by showing all the possible outcomes of an event. So let's have a look at this example. If you choose 1 burger, 1 side serve, and 1 drink, how many combinations, outcomes are possible? So let's just think together. We have 3 different burgers. So we have beef burger, we have chicken, and a fish. Then we have side serves of fries or salad, and then you have 2 drinks. Now, how can we calculate how many outcomes, and how can we draw a tree diagram? So have a look on the right. So basically we start and we have 3 burgers. We draw 3 branches for the burgers. Okay, so there's 3 options. Then we continue our branches. So we have then 2 branches coming from each burger. We have chips and salad. And what we do is we multiply. So we have 3 burger options. We have 2 side serves options. So 3 multiplied by 2. And then we have 2 drinks. So 3 multiplied by 2, and we have 12 outcomes. So you can also count it yourselves to see if you can have 12 possible different meals. Okay, so you can have beef, chips, and Coke. You can have beef burger, salad, and Coke. You can have chicken burger, chips, and Coke. You can have chicken burger, salad and Coke. You can have chicken burger, chips, and juice. So just have a look at all these possible combinations and see if it makes sense. So there are 12 possible outcomes. Now please pay attention, because for homework you will have to try and draw a diagram yourself. So maybe possible breakfast things you can eat or something like that. Now let's keep moving forward. So how do we calculate the overall probabilities? Okay, so you can see here's a diagram. Now let's have a look. So if we are tossing a coin, we have heads and tails. Let's go back. So we have it's 50-50 chance. Okay, so we can have heads. Okay, we can have heads tails. We can have tails heads and tails tails. So this is tossing basically 2 coins. Now all of them have to add to 1. Now this is a little bit complicated, but hopefully you can understand. There will be a homework diagram you have to do. So every time you have probabilities, it adds up to 1. Now, if this is difficult to understand, it's okay. We will look at it in more detail when I come back. So don't worry if you can't really fully understand this. Now let's move forward. So as you remember, there's a probability line, okay? So 1 is certain, okay? This is why we have probabilities that have to add up to 1. Now 0 is impossible, and then we have 50 chance in the middle, even chance, and then unlikely or likely. So let's just remember a probability line. Okay, now food outcomes, tree diagram. So we have another example. For example, we have cereal in the morning, and we have 4 drinks: coffee, orange juice, tea, and water. We can have 4 outcomes. So 1 multiplied by 4. There's only 1 choice for food and 4 choices for drinks. So our 4 outcomes are on the right: cereal coffee, cereal orange juice, cereal tea, and cereal water. Now this is a very simple diagram, okay? So hopefully you guys understand how the tree diagram works so far. Now also there's an example of buying a new car. So you can have, you can see at the top there, sedan or hatchback. You can have 5 colors. You can have 2 body styles. You can have 5 colors, and you can have 3 models. How many total choices? Now, as you can see, we multiply 2 multiplied by 5 by 3, and we have 30 different choices that we can make. Now shown as a diagram. So just pause this if you want to have a better look. Now another example. How many outcomes? So we have 3 different shirts and we have 2 different pants. We multiply 3 by 2 and we have 6 outcomes. We have red and black, red and green, blue and black, blue and green, yellow, black, and yellow, green. Now, if you want to stop and take your time and copy one of these diagrams so you can understand better, please do, okay? Now, we're going to look at the video about probability, and this guy is going to explain how to choose what to wear. So you can also, for your homework, think of some ideas of what you're going to draw, what type of diagram.
Hey guys, Anthony here from Mashup Math. Thank you again for stopping by on this lesson where I'm going to show you how to use a tree diagram to figure out how many different outfits you have in your wardrobe. So let's go ahead and get right to it. Welcome back everyone, and thanks for joining us on this lesson where we are going to explore how we can use tree diagrams to find possible outcomes. So let's start off with a really easy question. How many possible outcomes are there to flipping a coin? Well, we should know that we only have 2 possible outcomes. We can either get heads or we can get tails. But what about the possible number of outcomes for flipping a coin twice in a row? Now, to find the possible number of outcomes here, we're going to construct a tree diagram. So our first flip, we're either going to end up with heads or with tails. So if our first flip is heads, then our second flip has 2 options. And again, those options are heads or tails. And the same goes if our first flip lands on tails. Our second flip has 2 options, again, either heads or tails. So now our completed tree diagram will help us to find the exact number of possible outcomes for this scenario. One outcome is heads on the first flip and heads on the second flip. Another is heads on the first flip and tails on the second flip. You could also get tails on the first flip and heads on the second flip. Or you could get tails on the first and second flip. And we see here that we have 1, 2, 3, 4 possible outcomes for this scenario of flipping a coin twice in a row.
Ooh.
So now we're ready to extend our understanding of tree diagrams to a more complex example where we're going to help Josh figure out how many different outfits he can make with what he has in his wardrobe. So what we're looking to find is what is the total number of different combinations of outfits that we can make with the following choices. So he has 3 tops, a blue t-shirt, a gray hoodie, and a red plaid dress shirt. He also has 2 pairs of jeans to choose from, blue jeans and black jeans. And finally, he has 3 pairs of sneakers, which are running shoes, casual shoes, and high tops. So now, with these options in mind, we're ready to construct a tree diagram to explore how many different combinations exist for his outfit. So let's start off with tops first. He has 3 choices. So we have 3 branches, and one is the blue t-shirt, one is the gray hoodie, and one is the red plaid dress shirt. Now for each top, there are 2 options for jeans. So we make 2 branches from each option for a top, and show either the blue jeans or the black jeans. And finally, each pair of jeans has 3 options for sneakers. So I draw 3 branches from each pair and include each option of sneaker. So now we have completed our tree diagram, and now we can use it to figure out the total number of possible combinations. Now, for example, one of these outfit combinations is the blue t-shirt with black jeans and casual sneaker. Another possible outfit combination would be the red plaid shirt with black jeans and the high top sneaker. And we can figure out the total number of different outfit combinations by counting all of the shoes in the bottom branches of the tree diagram. And if we count all of these shoes, we should get a total of 18 different outfit combinations. Now here's a little shortcut for finding this total number without actually constructing a tree diagram. Notice if we take 3, the total number of tops, 2 the total number of jean choices, and 3 the total number of sneakers, and multiply those 3 values together, 3 times 2 times 3, okay? We know that 3 times 2 is just 6, and 6 times 3 is equal to 18, which was the total number of outfit combinations that we found by using the tree diagram. So just be aware of how to construct the tree diagram to represent scenarios like this, and also be aware of the fact that you can multiply the number of choices together, and that product will represent the total number of combinations for whatever it is you're looking at. So in this scenario, Josh had 18 outfit combination choices, and it looks like he went with the red plaid shirt with black jeans and high tops. Not bad, looking good. We'll see you guys next time. Peace.
Okay, so that was the video about making choices when it comes to outfit. Now let's look at this one. So how many outcomes do we get now? If you can open your notebook and write down what you think. So just remember what that video shown before. So think about how many types of pants, how many types of shirts, and how many types of shoes. Okay, and see if you can figure out what is the answer. Hopefully you all can. And so it looks like this guy has chosen to wear a black shirt and brown pants and black shoes. So there are 12 outcomes altogether. So we can multiply the pants. So they have blue and brown pants, and then they have 3 different shirts. And then there are 2 different shoes, right? So 3 multiplied by 2 and multiplied by 2. It should be 3. Sorry, it should be 2 types of shoes. So I made a little mistake there. There are 2 different types of shoes. Okay, so it should be 12 outcomes. Hopefully you guys understood this. Now let's keep moving forward. So open your notebook, make a tree diagram for the possible outcomes. So have a look at this one and draw a tree diagram. Now you will probably need a bit more time, so just pause this video. Okay, pause this video and draw the tree diagram. I will show you the answer in a minute. So if you can make a start and try and construct now a diagram similar to this one, okay, that shows, so have a look at this one more time. Now have a look at this one. So we have 3 different shirts, 2 different pants, and 1 type of shoe. So if you can construct a tree diagram for this one, I'd like you now to pause this, okay, and do it, because I know you'll need time to do this. Okay, it shouldn't take you more than a couple of minutes anyway, like just to quickly draw this. Now you don't have to make your drawing really nice. You can just also write red shirt, green shirt, you know, and just draw the branches. Now I'm going to show you the answer, so if you need more time, please pause it. Now this is the answer. So we have 2 pants, and then we have 3 different shirts and 1 type of shoe. So this is the way your tree, probability tree should look like. And to get the amount of choices, we multiply 2 by 3 by 1. So hopefully you guys have drawn this. If you haven't, please do it now. And then if you put them together like this, we can see we have 6 choices. Now I hope everyone is going well. Let's look at coin. So we're moving on to have a look at the coin choices. So if you can copy this as well to your notebook. So this is a very simple basic tree diagram. So we have on the first toss of the coin we have 2 choices. So 50%, 50%. Okay, and you can see they're half and half, and we have heads or tails. So this is just one toss of the coin, and these are the results we would get. So pause this and just copy this into your notebook. Now it's going to get a little bit more complicated. So then when we toss 2 coins, okay, we can have 4 possible outcomes. So we can have heads, heads, as you can see there. We can have heads, tails. We can have tails, heads, and tails, tails. So this is the probability of tossing 2 coins. So each of those would be 25% because it all needs to be added up to 1 or 100%. Now, probability of tossing 3 coins, okay? So it's getting more and more complicated. Now, this one, as you remember, has 8 different outcomes. So we just keep drawing the branches, adding on to this one. We keep adding on another one. So we can have heads, heads, heads. We can have heads, heads, tails. We can have heads, tails, heads, and so on. So this is the bigger one. Now, if you want to try and draw these to see if you can understand it, just copy some of these into your notebook. There will be a homework question where you have to fill in the tree diagram and finish filling in. We can also use a tree diagram to help list all the possible outcomes of a dice and a coin. So this is, we can have heads or tails, and we can have 1, 2, 3, 4, 5, 6 on the dice. Or we can have tail and 1, 2, 3, 4, 5, 6 on the dice. So these are the possible outcomes for the coin and the dice. Now, let's look at one more question. So, Jane wants ice cream. The ice cream shop has the above tree diagram in the window to show customers possible combinations of ice cream they sell. So have a look at this tree diagram, and there will be some questions I will ask you. So you can have ice cream in a cone, in a waffle cone, and then you can have it in a cup. And then there are 2 flavors, vanilla and chocolate. And then you can have extras like sprinkles, nuts, or strawberries, 3 extras. Now let's have a look at the questions. So if you can write these questions in your notebook. So open your notebook and see if you can answer these questions from the diagram. So how many total outcomes are there? Okay, how many combinations would there be if the ice cream shop added another flavor? So remember, the flavor is one of the flavors is vanilla and another one is chocolate. So if we add another one. Now question 5, how many combinations can Jane get with vanilla ice cream? So vanilla ice cream, how many combinations? How many combinations can Jane get if the ice shop runs out of nuts? So no nuts. And how many combinations can she get with chocolate and strawberries? So if you can pause this and just think, answer these questions, it might take you like, I don't know, maybe 3 minutes, depending how well you're understanding the tree diagrams. So just pause this lesson, and I'm about to show you the answers, and hopefully the answers that I got last night are all correct and I didn't make any little mistakes. So I was recording this lesson a little bit late, so let's check. So how many total outcomes? We multiply 2 by 2 flavors and by 3 different extras. So we have 12 outcomes. Now hopefully you're getting these answers. How many combinations would it be if the ice cream shop added another flavor? So because we have 2 flavors, another one would make it 3. So we multiply 2 by 3 by 3. We have 18 outcomes. Now how many combinations can Jane get with vanilla ice cream? Vanilla ice cream she can get, I got 6 combinations. Hopefully you also got that. How many combinations can Jane get if the ice shop runs out of nuts? So no more nuts. We multiply the 2 by 2 by 2. So I got 8. And how many combinations can she get with chocolate and strawberries? Chocolate and strawberries. So she can get, I got 2. So we have cone, chocolate, strawberries, and we have cup, chocolate, strawberries. So I think we have 2 if we want to have chocolate and strawberries. Okay, so these are the answers for this one. If you need more time, please stop this video. Now, we're going to just do a few questions, a little bit of review. I think we have about a couple of minutes left of the lesson, so we will, I'm not sure if we have enough time. Let's think. We may have to skip this one actually. I did prepare to do this, but we are out of time. So I will just show you a couple of more things. Maybe I will show you this one because it will be quicker. there's two games, there's one game I wanted to show you. So let's look at the homework though first. So this is your homework. I will send the PDFs and you need to print these out. So mass probability tree diagrams, you need to fill these in. If you have any questions, please let me know. So the first one is one coin toss, the next one is tossing two coins. So if you can go back to the video and have a look how to finish filling this in. And then analyze the diagram and answer the questions. And the question 4 is draw your own tree diagram. Okay, now we're going to look at this game. So ask your parents if they let you copy this link and you can play the probability game with cards. Now I will get out of this and I will show you the game. Okay, now this is the game. So very quickly, I will just restart this. Now you can make this a full deck. So you can make it, you can decide how many cards. So I'll make it a total of 11. Now you can play single suit or full deck. So I'll play full deck. Now this is how it goes. You need to use your probability knowledge to decide if the next card is going to be higher or lower. So we have Jack. Now I think that is going to be lower. Now you can also check with a hint. Okay. Higher is 8/51, lower is 40/51. So it's definitely, you can see here, it's a higher probability of a card being lower. So let's go with the hint and try lower. Actually, it was higher, but the probability for it being lower was higher. Now, if you look at the king, let's look at the hint. So it's 94% of it being lower. So let's go with lower. That's right, here we go. Now, if you look at another hint, should we choose higher or lower? It says there's a higher percentage of it being higher. Let's go with that. Okay, it's higher. And so on. So now I think I will just use my probability knowledge. I think it's going to be lower. Now remember 6, it is a higher probability of it being higher. So let's go with that. But actually it's 5. Now let's try higher again. And it's lower. So you just don't know. Now I'll try lower. Yes. I'll try higher. Try lower. Try higher. But so this is the game. So you can restart it again and try again. So let's go back to this. This is the address for it. Okay. Just copy this and see if your parents let you play this one. Okay, it's a good one to see if you can work out the probability of which card will be higher or lower. Okay guys, we will do this game next time. Okay, so remember we played Jeopardy, but we are out of time, so don't forget to do your homework sheets. These are your homework sheets, and I will see you next time.